Our project is HealthFederated, which is where we use vertical federated learning and blockchain to accomplish a binary classification task on medical image data from different hospitals, where we'll be using blockchain in the form of a smart contract to perform aggregation in our federated learning. And at a high level, this is what our model architecture looks like, where we have some number of hospitals, each with image data, and they perform a client-side training. And then in a forward pass, they apply differential privacy mechanism. This gets sent to the aggregator in the form of embeddings that have been applied some differential privacy noise. The aggregator will perform a summation and send this to our central server component, where we perform a classification and send back the clients the updated gradients. So to run this, you first have to clone the repository and install all the dependencies listed here. And you can also retrieve a sample dataset that we have with this Google Drive link. And once you have the source code, you can simply run demo.py with various arguments, and here are all the arguments that we provide. So we have the data path, which is the path to the dataset, the data size, which is the portion of the dataset to use, and we have a theta, which is the DP noise value, and an argument to specify whether or not to utilize blockchain. So I've actually went ahead and run this already, and these are the arguments I used with demo.py with the data size of 0.0125, which is 10 samples, and with blockchain equal to true. And once you run it, it'll run for 5 epochs, and it'll print the time taken, validation loss and accuracy, and also the test loss and accuracy as well. And so here are the results for my demo run here. Obviously this will not be super high because I use a very small data size value, but you could also use much bigger values, and I have the results in our repository as well. And we also get as output some graphs here. So we have a figure with epoch on the x-axis and accuracy on the y-axis. Then we also get another graph, which is the epoch on the x-axis and the loss on the y-axis. And we also have a testing plan where we want to test the smart contract component by itself, because obviously running the whole demo takes a long time. So ideally we'd want to test the functionality of the smart contract in a standalone way. So we provided a way to do that as well via this test aggregator.py, which will just test our aggregator smart contract. And you can simply run python test aggregator.py once all the proper dependencies are installed, and it'll just automatically run a whole bunch of unit tests that we have here. And I have comments for all the unit tests here, and these test all the various functionalities of the aggregator, including updating client weights and the aggregation algorithm and various other functions.
So the AI component of our project has been implemented in two different files. So the first file is models.py, which has our local model. So the local model has basically two options, BGG19 and ResNet50, and we basically concatenate the weights from the local models, and that happens on the client. Um, Now in this VFL without blockchain.py file, this has the code for the vertical federated learning. It basically makes use of the local models from model.py for vertical federated learning, and both models.py and this file use PyTorch. And demo.py has the code similar to VFL without blockchain.py, but it also incorporates blockchain, and we have already shown this before. For the blockchain component, we use the Solidity smart contract, which is called aggregator.sol. This contract has various functions. So we have a function called add participant, which basically can be called from a client address to add a new client or a hospital. And this is a getter function for the aggregated weights. And so the most important function is the aggregate function, which basically sums up the weights from different clients and sends it to the server. The server is in Python. So this is the blockchain component. And for the integration, we made use of a module called Web3 in Python, and the integration code is in this file, blockchain and BA for integration.py. So yeah, there are various modules we use, but the main module for the integration is the Web3 module. So basically what we do in this file is we create Ethereum accounts for different hospitals, and we compile the Solidity smart contract and deploy it on a backend called PyEVM backend. And with the addresses that we created for the clients, we basically run a simulation of the hospitals interacting with the smart contract by sending their local weight updates, and the smart contract processes that and sums it up and sends it to the server, and the server trains on those weights and sends it back to each client. So that most of that workflow is accomplished using this file.